All right, so question number 1 on Unit 4 review has a mapping, and it asks us to determine if each relation is a function, and if not, write a brief reasoning as to why not. So, our question is this a function? And the answer is yes, it is a function because each x value is unique. There's not any repeats. You're not coming out and using the same x value for any of your y values. So each input is unique for each output. All right, so number 2, same directions. It says determine if each function or each relation is a function, and if not, explain why. So this, again, looking at it, is a function. So the answer is yes. And actually, the reason why is, again, because each x is a unique value. There is no repeat of the x's. They are individual. So again, the directions are asking us to determine if each relation is a function. It is a function, and the reason here is if you try the vertical line test, you are never going to cross more than one point. It's always going to be one unique input for each output. Same directions here, asking, is this a function or not? And the answer here is no, it is not a function, because if you notice, the -1 and the +1 in the x values here, the x column, are being used for more than one output. So that is no, because your inputs are being shared, so they're not unique. All right, so again, the directions are the same thing. Determine if each relation is a function. So here, looking at this, the answer is no, because if you look at those 12s, the 12 is in x position more than once. So it is there more than once. You have the same x, the same input. So it is not a function. All right, so same rules on this. Determine if the relation is a function. Here, it is a yes, because each x value is unique. You don't have any repeats in your x values. All right, so the same rules. Determine if each relation is a function. This is an answer of yes. And your explanation would be to talk about the vertical line test. When you do the vertical line test on this graph, you are never going to cross through more than one point when you do a vertical line. All right, same directions here. Determine if each relation is a function. And the answer to this would be no, because if you look in your x values, the 3 repeats in the x value. So that would be why. That would be why it's a no, because you have to have a unique input for every output. Every input has to be unique. All right, so now we're into a different part of functions. So we know if f of x equals 2x plus 4, find f of -7. So to do this, I'm going to have f of -7 is equal to, everywhere I see an x, I'm going to plug in a -7. And now I'm just doing my math problem. 2 times -7 is -14. So keep that plus 4. -14 plus 4 is -10. So f of -7 equals -10. All right, so now our equation changed, and it says if g of x equals 2x squared minus 2x, find g of -5. So again, I'm going to plug in parentheses, a -5. Everywhere in this problem, you see an x. Then, again, like order of operations says, I've got to square that -5 before I can do the multiply times 2. -5 squared is -5 times -5, which is a positive 25. I'm going to go ahead and simplify this. -2 times -5 is a plus 10. This then equals 50 plus 10, because 2 times 25 equals 50. So your final answer would be g of -5 is equal to 60. All right, so now they give us h of x equals 6x squared minus 4. Find h of -2. No big deal that it's not f of x or g of x. It's just another way of representing the function. So when I ask for h of negative 2, again, wherever I see an x, I'm going to plug a negative 2 in to complete my math. Well, order of operations says I must do the exponent first. Negative 2 times negative 2 is a positive 4. So I'm going to drag that down. 6 times 4 is 24. So my final answer for h of negative 2 is 20. That's my final answer. All right, so in the back of this paper, it says part 2, and yes, it's numbered weird, so we're back at number 6. It asks, is the graph linear or nonlinear? Well, you're simply asking, is the graph just a line or is it something else? This case, we can see it is nonlinear. Then we move on. Number 7 asks us, where is the graph increasing? So I know we didn't focus this a lot in class. You're looking, again, from the graph from left to right. Is there anywhere in the graph that it is going up if you're reading it from left to right? No. Nowhere. It's increasing nowhere. Okay? Then 8 asks you, where is the graph decreasing? Well, from this graph, only looking at this graph, it starts at 0, and then it continues really forever. Okay? If you would see it looking like this, it would look like this. It would be 0, comma, infinity, if you would see that. Number 9 asks us the question, at 4 years, how much is it worth? So you're going to look down here at my 4, and you're going to match up where are you in the graph at this point. And I know my sketch is pretty rough here, but when you do that, you will see that it is at 10,000. Because again, you're reading the side of the graph tells you it's in a value of 1,000. So that's why it's 10,000. And then number 10 for this section says, how much will the vehicle increase or decrease in value by the 20th year? So you're estimating here. So I put down there, it's going to decrease because that happens to cars all the time, the second you drive it off the lot. And it looks like on this graph, it's decreasing by 20,000. And really, that's what you do. You just be basically estimating it. All right, number 11 then on the back side, here in part 3, ask us, is the sequence below an arithmetic sequence? And remember, arithmetic sequence means it must be going up or going down by the same amount each time. Well, this is not an arithmetic sequence. It is, in fact, another type, which is geometric, because if you notice, it's being multiplied by 2 each time, but it is not being added or subtracted by the same amount each time. All right, so these directions said, find the next 3 terms of the sequence below. So it is indeed a sequence. You have to determine what's going on here. Well, when I look at this, the difference that is occurring each time, 19 minus 13 is a negative 6, or minus 6. 13 minus 7 is, again, it's going down by 6. 7 minus 1 is going down by 6. 1 getting to negative 5, it's going down by 6. So my changing is just going down by 6 each time. So if I continue this, my next ones are going to be negative 11, and then I keep going, negative 17, and negative 23. That would be my sequence. All right, number 13 here on this back page in part 3, asks us to write an equation for the nth term. We've been doing this. This is not new. It just maybe is worded differently. This is our a sub n is equal to a sub 1 plus n minus 1 times d, where a sub 1 is this first value right there, and your d value is the difference that is occurring for each terms in the sequence. So here I've got my a sub n equals, my a sub 1 is 10, and my difference, if you notice what's going on here, is I'm increasing by 15 every single time. So I'm going to have a 15 there. Now, of course, I'm not done. I need to keep going with this to simplify things. So a sub n equals that 10, plus, remember to distribute that 15 through. So you're going to get plus a 15n minus 15. Again, we want to clean this up because we can. and we get 15n minus 5 because we have a plus 10 and we have a minus 15. So 10 minus 15 would give me my negative 5. All right, so they asked us to deal with the same sequence of the 10, 25, 40, 55, 70, and we found the equation already on our previous problem. So a sub n was equal to 15n minus 5, and now they want us to find the 18th term, So all I'm going to do is I'm going to say a sub 18. So wherever I see an n, since I replaced the n with an 18, I'm going to replace the n over here with an 18. So I'm going to have 15 times 18 minus 5. So you get out your calculator and you figure out that that's 270 minus 5. So a sub 18 is equal to 265, or the 18th term in this sequence is indeed 265. All right, here's the directions for this one. Asks us to write an equation for the nth term for the sequence 94, 91, 81, 85, 82. So again, our formula is a sub n equals a sub 1 plus n minus 1 times d, where a sub 1 equals this first term of the sequence, and our d value equals the difference that's going on in the sequence from number to number. So in this case, we've got our a sub 1 is 94, and our n minus 1 stays there, and our d value in this problem is a minus 3, because each time we are subtracting 3 in these problems. So then when I keep going and simplify here, I get 94 plus, remember this negative 3 is being distributed in both locations here. So I'm going to have a minus 3n, and then I'm going to have a plus 3. So again, go ahead and simplify it down, and you're going to get a negative 3n, and then you've got 94 plus 3, which simplifies to a plus 97. So your nth term equation is going to be negative 3n plus 97.